Okay, so for your trig proofs, all right, again, you're trying to show that one side equals another. So for this first one, okay, and I don't know why this does this. Everything goes blank. Okay, I'm going to work on the left side, all right, so I'm going to change everything so that it's sine and cosine, okay. So I have 1 plus cosine of A divided by sine of A over 1 over sine of A minus sine squared. Okay. Now when you do that, okay, when you do this fraction, right, the sines are going to cancel out. So you just got cosine now. All right, now if you put both 1 minus sine squared together, that's going to give you cosine squared. All right, that's an identity. All right, and then obviously they both have cosine in common, so you can factor that out. And then you're left with your proof. Okay, so for number 2, again, I think it's easier to do the addition side than the multiplication. So we're going to do sine over cosine plus cosine over sine. Okay, so we need a common denominator now. So I'm going to multiply this side by sine over sine. And this side here by cosine over cosine. Okay, so that's going to give me sine squared over sine cosine. And then this side is going to be cosine squared over sine cosine. Now, if you put the top together, sine squared plus cosine squared, that's 1. All right. Now, if you look at the other side, you have two functions, okay? So how can you come up with these two functions from one fraction? Well, if you split the denominator up and make it like that, okay, then this is going to give you cosecant times secant, which is what you have on the other side. Okay, for number 3, I'm going to do the right side now. Okay, so this is going to be 1 over sine minus sine. Okay, so you're going to need to multiply that second term by sine over sine. So you make it one term. Okay, so when you do that, right, you're going to have 1 over sine minus sine squared over sine. Okay, now 1 minus sine squared, right, is going to become cosine squared. Okay, now cosine squared, right, you really know is cosine times cosine. Correct? Now, if you split that up, right, you're going to be left with cosine over sine times 1 over sine, right? Oh, I'm sorry. I made a mistake. You're left with cosine because you've already used the sine term. Sorry. Okay, so cosine over sine becomes cotangent, and then you got cotangent times cosine, right? Now, you need secant there in the bottom, right? So, well, what is cosine the same thing as? Well, that's the same thing as 1 over secant, right? Now, if you put these together, you got cotangent over secant. Okay, so for number 4, I'm going to do the left side. Okay, now the reason I'm picking that is because of what I have here in my denominator. Okay, I can multiply that by the conjugate of that. All right, so this is going to be 1 minus cosine, and then on the bottom, on the top, same thing. Okay. Now, when you distribute the top, right, you got secant times 1, which is secant, and then you have secant times cosine. Well, those two things are opposites of each other, so they're just going to become 1. And then on the bottom, you got 1 minus cosine squared. All right? Now, 1 minus cosine squared becomes sine squared. Okay. Now, kind of very similar to the last one, right? We have the secant minus 1, right? We need that, right? So I'm going to leave that alone. Okay, but if I bring this sine squared and I put it out front, I have to make it 1 over sine squared. Okay, now when I do that, that becomes cosecant squared. And that's what you need. Okay, so for number 5, I believe you can do it either side, all right? Now, what I'm going to do is I'm going to be using the left side. Okay, so the left side, right, I can make sine of A over cosine of A minus 1 over cosine of A. Okay, and we're squaring that. All right, now if I put that together, that's going to be sine of A minus 1 squared over cosine squared. Right, you can make it one fraction, and then if you square both the top and the bottom, right, that's what you're going to get. Okay. Now, what is cosine squared the same thing as? Well, that's the same thing as 1 minus sine squared, right? So you got sine of A minus 1 squared over 1 minus sine squared of A, okay? Now, if you expand the top and the bottom out, right, you're going to be left with sine of A minus 1, sine of A minus 1 over 1 minus sine of A, 1 plus sine of A. Okay, now look at what you need on the other side. You need the 1 plus sine of A in the denominator, okay, and you only need 1 minus sine of A in the top, okay? So you need to somehow figure out how could we cancel this term, right? So what you can do is you can take out a negative 1 from the first sine of A minus 1, okay? So if you do that, right, it's negative 1 times sine of A. I'm sorry. If you take out the negative 1 from the first factor there, right, that's going to become 1 minus sine of A, okay, times sine of A minus 1. Okay, over 1 minus sine of A times 1 plus sine of A. Okay, so obviously these are going to cancel, right? Now, if you take this negative 1 that you factored out and you distribute it to So what you have left in the top, right, you're going to be left with 1 minus sine of A over 1 plus sine of A, okay, which is what you need. Okay, so for number 6 now, all right, what I'm going to do is I'm going to factor out the left side, okay? So this is really sine squared minus cosine squared times sine squared plus cosine squared, right? Now, you know sine squared plus cosine squared is just going to become 1, okay? Now, you have sine squared minus cosine squared, okay? Now, you need 2 cosine squared, right? So how can you possibly change sine squared, right? Well, if you make that 1 minus cosine squared, and you simplify, now you got 1 minus 2 cosine squared. Okay. So for number 7, this is like another factoring problem. Okay. So if you can imagine, you have like x to the 4th minus 2x squared y squared plus y to the 4th, right? How would you factor that, right? That would be really just x squared minus y squared times x squared minus y squared, right? We're going to do the same thing here. We're going to treat secant like the x term, and then you're going to treat tangent like the y term. Okay, so that's going to give you secant squared of d minus tangent squared of d squared, right? Okay. Now, if you do secant squared minus tangent squared, okay, that's an identity, right? That's a Pythagorean identity, right? So this is just going to be left with 1, and then 1 squared is 1. All right, and then if you kind of doing the same thing here, tangent squared minus secant squared, right? If you know 1 plus tangent squared is secant squared, right? If you subtract the secant squared over and then subtract the 1 over, right? This is just going to become negative 1, which obviously is just negative 1. Okay, so for number 9, you have 1 over cosecant plus cotangent equals 1 minus cosine over sine. Okay. So what I think I'm going to do the left side. All right, I'm going to change everything into sine and cosine because that's what the right side has. So you got 1 over sine plus cosine over sine, right? Now, if you put those together, right, you got 1 plus cosine over sine, right? So if you do 1 divided by that fraction, you really have the reciprocal. All right, now you're pretty close to what you need on the other side, right? Now this factor here, 1 plus cosine in the denominator, all right, that's 1/2 of a conjugate pair, right? So you can multiply the top and the bottom by its opposite, right? Now if you do that, right, you're left with sine of y times 1 minus cosine divided by 1 minus cosine squared, right? Now what do you know 1 minus cosine squared becomes? Well, that's just sine squared. Okay, and then the sine of y in the top is going to cancel out one of them in the bottom. So then you got 1 minus cosine over sine, which is what you need. Okay, and then number 10. Now number 10 looks kind of crazy, right? Now you got secant plus tangent and secant minus tangent, right? Now, you know that 1 plus tangent squared is secant squared, right? So we know then that 1 must be secant squared minus tangent squared, okay? Now how do you come up with secant squared minus tangent squared if you factor it, right? So you got secant minus tangent, and then secant plus tangent, right? So how many of these pairs can we come up with based off of what we have here on the left side? Okay, well, I have 3 secant plus tangents, and I have 4 secant minus tangents, okay? So if I put 3 pairs together, that means I have 1 secant minus tangent left over, right? So if I write this out now, okay, I got secant minus tangent times secant plus tangent, right? If I multiply those together, and I have 3 pairs of these, all right, and that still leaves me with 1 secant minus tangent left over, right? Because that was raised to the 4th. Okay. Now we already know that if we multiply here, this is going to be secant squared minus tangent squared to the 3rd power. Okay, and we already know that that comes out to be 1. Okay, so this whole thing just becomes 1. Okay, now secant minus tangent. If you change that to be just sine and cosine, you get 1 minus sine over cosine, which is what you need. Okay, so you're looking to just put pairs together to come up with your answer. Okay, so number 11, all right, this becomes sine of k over cosine of k minus 1 over cosine of k, not x, that's k. All right, now if you put them together, sine of k minus 1 over cosine of k. Okay, so for number 12, all right, we're going to put them together. All right, so that means I need cosine over cosine to the first term. And then we also need sine over sine on the second term. Okay, now when I multiply cosine times secant, they're reciprocals of each other. Okay, so that just becomes 1. So you got 1 over cosine w sine w minus sine squared over sine w cosine w, right? Okay, now in the top now I got 1 minus sine squared, which you guys know becomes cosine squared. Okay, now if you simplify that, right, this cosine is going to cancel out one of these. All right, so now you got cosine w over sine w, which is cotangent of w. And that's your proof. Okay, so for number 13, let's see. Tan of x minus 1, secant minus cosecant over cosecant. Okay. I'm going to do the right side. I know I told you probably subtraction's probably easier, but I just think that there's more terms over there on the right side. Okay, so I have a single term in the denominator, so I'm going to make this secant over cosecant minus cosecant over cosecant, right? Now, this becomes 1 over cosine of x divided by 1 over sine of x minus 1. Okay, now it's 1 over cosine times the reciprocal, which is just sine, so it's sine over cosine minus 1, which is then tangent minus 1. Okay, so for number 14, okay, we're gonna multiply here. So cosecant times sine, they're reciprocal, so it just becomes 1. And then you got cosecant times cosine. All right, so that's cosecant times cosine. Okay, so 1 plus. Now cosecant is 1 over sine. So this becomes now cosine over sine, which is cotangent. Okay, so for 15, I'm going to put everything in sine and cosine. I'm sure you guys see a pattern at this point. You know, the reason that you do that is because so many functions, you know, go back to sine and cosine. So it's typically helpful to do that. Okay, now, we want to get rid of these fractions, okay? So we're going to multiply through by cosine over cosine, correct? So when I do that, right, I get sine cosine plus sine divided by cosine plus 1. Okay, now, what does the top have in common? Well, that's got sine in common, so that's cosine plus 1 over cosine plus 1, which cancels, and you're left with sine. Okay, so for number 16, okay, so we're going to do the right side. All right, so we got sine squared over cosine squared minus sine squared, okay? So we're going to multiply by a common denominator, which would be cosine squared over cosine squared. Okay, so then that's going to give me sine squared over cosine squared minus sine squared cosine squared over cosine squared. Okay, so now you got sine squared in common, so you can factor that out. So it'll be 1 minus cosine squared over cosine squared, right? Okay, now what you want to do is you want to split this this product up, okay? So you're going to put this together as a fraction, okay? And then this is going to be a separate fraction, all right? But that's going to be over 1 because you're already using the cosine squared in the other term. So you got sine squared over cosine squared times 1 minus cosine squared, okay? Sine squared over cosine squared is tangent. And then 1 minus cosine squared is sine squared. Okay, number 17. Now I think you can do either side, right? I think I'm going to do the right side. So you should recognize that, okay, I have a half of a conjugate here. So I'm going to multiply by the opposite. So you got 1 plus cosine over 1 plus cosine. Okay. So that's going to give me cosecant times 1 plus cosine divided by 1 minus cosine squared. Okay. Now, you already know that 1 minus cosine squared becomes sine squared, right? All right, now you have 1 plus cosine in the top, which is what you need. Now, this cosecant, right, is the same thing as doing 1 over sine of x, right? Okay, now if you want to get rid of that fraction, okay, you can simply just multiply through by that term. Okay, and when you do that, technically you only have one term here in the top, right? It's 1 plus cosine over sine. Okay, and when you multiply it by sine, it's going to cancel 1 over sine. Okay, and then you got 1 plus cosine of x over sine cubed. Okay, we got 5 left. Okay. Okay, so for number 18, you got sine of t over cosine of t over 1 over cosine of t plus cosine of t over sine of t over 1 over sine of t. All right. Now, if you multiply through, right, the cosines are going to cancel, so you're left with sine, and then the sines are going to cancel, and you're left with cosine. Okay, number 19. Okay, I think you can probably do either side, all right? Okay, so you should recognize that, okay, you have kind of opposites here on the left side. Now, if you multiply through by sine plus cosine, let's walk through that. So if you do sine plus cosine in the top and the bottom, okay, what are you going to be left with? Well, that's going to leave you with sine squared minus cosine squared in the top. And then on the bottom, that's going to leave you with sine squared plus 2 sine cosine plus cosine squared, right? Now, what do you need in the top here? You need 2 sine squared, right? So what is cosine squared the same thing as? Well, that's the same thing as 1 minus sine squared, right? And then on the bottom, you can put sine squared and cosine squared together to give you 1. Okay, so now you have your denominator, okay? And now if you distribute your negative here in the top, right, you got sine squared minus 1 plus sine squared. And then if you combine your like terms, now you got 2 sine squared minus 1 over 1 plus 2 sine cosine. Okay, so for number 20, what I'm going to do is I'm going to multiply out the left side. Okay, so that's going to give me sine squared plus 2 sine cosine plus cosine squared times tangent. Okay, now sine squared and cosine squared is just going to become 1. So 1 plus 2 sine cosine. Okay, now we could probably change tangent to be sine over cosine, right? Okay, now if you distribute now, you're going to be left with sine over cosine plus, now when you do 2 sine cosine over cosine, right, cosines are going to cancel. So then you're left with just 2 sine squared, right? And you already know that sine over cosine is tangent. So there you go. Okay, 21. I think you could probably do either side. I think the left side, see how you have on the bottom here, you have one factor of a difference of 2 squares, and this is a difference of 2 squares. So if you factor the top, you got cosecant minus 1, cosecant plus 1 over cosecant plus 1, which cancels. And then you got cosecant minus 1, which is this 1 over sine minus 1. And then the last one. Okay, now the last one is also a factoring problem, okay? Now we talked about in the notes that it's probably helpful to change everything into the same function, okay? Now I see that I have tangent here on the right side, so it's probably easier if I change this and this to be in terms of tangent, right? Now secant squared is 1 plus tangent squared. All right, now if I simplify the top, I got tangent squared minus 6 tangent plus 7. No, sorry, plus 8. And then on the bottom, I got tangent squared minus 4. Okay, now in the top, it's like you got a squared minus 6a plus 8, right? How would you factor that? Well, factors of 8 that add up to be negative 6. So you got minus 4 and then minus 2. Then on the bottom, you got tan of x minus 2, tan of x plus 2. So then those cancel, and then you're left with tan of x minus 4 over tan of x plus 2. And that's it. Okay, guys, so if you have any questions, let me know.